I will show. Where is my piece? Here.
Half our global CO2 emissions by 2030. So that means in the next 10 years, roughly, global CO2 emission reductions in half. Then by 2050, 20 years later, we would have to be at net zero CO2 emissions. And in the second half of the century, we need a significant scale of carbon dioxide removal. But the scale of that varies quite a bit. But these are sort of the three main characteristics of 1.5 degree pathways: halving CO2 emissions 2030, net zero CO2 in 2050, carbon dioxide removal in the second half of the century. Now, it doesn't matter at which of those lines you look at, how much of this carbon dioxide removal in particular we need. And these are 4 scenarios, and the P1, P2, and P3 are all in the blue envelope, and the P4 is in the gray envelope that I just showed. So let's focus on the P1, P2, and P3. And the main message of this graph is that we still have something to choose. Basically, we don't need to do 20 gigatons of bioenergy and CCS, which is the P4 one, in order to limit warming to 1.5 degrees. If we focus on P1, where the gray part is the positive CO2 emissions as a consequence of fossil fuels, essentially, and the brown is the positive or negative emissions as a result of agriculture, forestry, and other land use, and yellow is negative emissions, so carbon dioxide removals by bioenergy and carbon dioxide and geological storage of CO2. So that basically you make bioelectricity and you capture the CO2 emissions and put them underground. So you have a net reduction of carbon dioxide from the atmosphere, not just of emissions, but from the atmosphere. So this P1 scenario is called the low energy demand scenario. And what it does, it reduces, for instance, through behavioral changes, energy demand quite significantly already early on. And that means that in order to not use up, you're not using up your carbon budget so quickly, so that means you don't need so many negative emissions in the latter half of the century. If you contrast that with P3, which is a very different world, it continues with emissions for a little bit longer. And because we're depleting the carbon budget, we need more negative emissions or more carbon dioxide removal later on. And because at some point afforestation and reforestation runs against barriers and other carbon dioxide removal options are not yet in the models use a lot of bioenergy and carbon dioxide capture and storage in order to sort of replenish that carbon budget, if you like. Now, this bioenergy and carbon dioxide capture and storage is at the moment not yet a mature technology. So in order to make that happen at the huge scale that we're looking at here, we're talking about 10 gigatons of CO2, which is 1/4 of the total positive emissions we have now. So the scale of that is enormous. So with a scenario like that, we are taking a huge bet on the future, on those technologies really working. It's also very clear that with these types of emission reductions, we need more than just a couple of options, technological options to be implemented. We need basically systemic changes in 4 systems we identified, and I hope my slide